Good morning, everybody. We're going to be finishing up 4C today. So, for the past couple days, we used the properties of logarithms to expand and condense. Yesterday, we focused on condensing, which means rewrite the expression into a single logarithm. So, condense means make smaller. And today we're going to be expanding, so that's going to mean make the expressions bigger. So they're going to be written as one logarithm, and we are rewriting it with multiple logarithms. So we're still using these same three properties here. And so we're looking at these last three examples here. So apply the properties of logarithms to rewrite each expression as a sum of terms involving numbers log x and log y. So in other words, we are trying to expand this into a sum of terms. So instead of just one logarithm, we're trying to rewrite it as separate logarithms. All right, so let's look at A. So we have log base 4 of 3x squared. So this is actually two terms. The 3 is one term, and then the x squared is another. So this is in the form log base b of m times n. So when I rewrite this, that means the m is 3 and the n is x squared. So when I rewrite this, I'm going to rewrite it as two separate logarithms with a plus sign in between. So I'm going to scroll up here. I'm using property number 1 right here. So if it's written as log base b of m times n, I can rewrite it as two separate logarithms, log base b of m plus log base b of n. So when I rewrite this, I'm going to have log base 4 of 3 plus, so I'm going to have a plus sign in between since m times n was multiplied, plus log base 4 of x squared. So I have separated it into two logarithms, but I'm not done yet because I still have this squared, this 2 in the exponent. So now I'm using the third property. Again, I'm going to scroll up here. So this property, if we have a number in the exponent, we can move it to the front in the constant so that it's multiplied by the logarithm. So this 2, I'm going to move to the front. And so this expression will become 2 log base 4 of x. So I have log base 4 of 3 plus 2 log base 4 of x. So we know it's expanded all the way when each logarithm is just a logarithm of one single term. So like this one is just logarithm of 3, this one is just logarithm of x. So that is our answer there. That's expanded form. All right, let's look at B. So on B, notice we have actually three terms. We have x, y, and z. So that means when we are done, we're going to have three separate logarithms. So we have log base 2 of x squared over yz cubed. Now, since there is more than two terms, I am going to just do one step at a time. So the way this is written right now, this is in the form log base b of m divided by n. So the top is m and the bottom is n. So when I rewrite it, I'm going to use the second property that I have listed up here. I'm going to scroll back up, which is if we have log base b of m divided by n, I can rewrite it as log base b of m minus log base b of n. So I'm going to rewrite it with a minus in between. So I would write this as log base 2 of x squared minus log base 2 of y z cubed. Okay. So that's using the second property, but I am not done expanding that yet. So now I have to expand this expression more because I have log base 2 of m, or this is in the form log base 2 of m times n. So in this case, the m is the y and the n is z cubed. So when I rewrite this, since these are multiplied, there's going to be a plus sign in between the two logarithms. So I'm going to have log base 2 of y plus log base 2 of z cubed. Okay, now we have to be careful the way we write this. The way we write our final expression, because I have this log base 2 of x squared, and I'm subtracting this whole expression. So when I rewrite it, I have to I can put the whole thing in parentheses like this. So I have to have the log base 2 of y plus the log base 2 of z cubed in parentheses because I'm showing that I'm subtracting this entire expression, and this is equivalent to this expression. The other thing you could do is rewrite it with distributing the negative. You'd have to distribute, it's like a -1 to both of these. So these would both end up being minus. I'm going to leave it like this for now, and then I'll show you another way we can write it. So I've used the two properties with the subtraction and multiplication, but I still need to deal with exponents. So this first expression has an exponent. So this 2 can go in the front. So I can rewrite this as 2 log base 2 of x. Then I'm subtracting, and remember this is all in parentheses. This one doesn't have a power, so that's just going to stay log base 2 of y plus, right here, this 3 that's in the exponent can move to the constant in the front. So then that would become 3 log base 2 of z. Now, again, notice I have this whole expression in parentheses. So this is one way you can write it. You can leave it with the parentheses here. The other way we can write it is I can distribute this negative to both of these. And then if I rewrote it that way, it'd look like this. 2 log base 2 of x, that doesn't change. This would be minus log base 2 of y. And then I'm also distributing the negative to this. I'm subtracting both of these terms. So then I'd have minus 3 log base 2 of z. And so that's another way to write that as well. So either you need the parentheses around these, or you can distribute the negative, the minus, and make those both minus. All right, so that's what B looks like. So we've got one more example. Now this one, something you'll notice is this has a radical in it. So before we can use any of the properties, we actually need to rewrite the radical as an exponent. And so hopefully you remember we reviewed yesterday. I'm going to flip back. That a radical can be rewritten as a fraction exponent. So this one is a square root of x. So I can rewrite that as x to the 1/2 power. So we have to know that in order to rewrite this. Otherwise, there's nothing we can do to simplify. So it is really important to be able to rewrite radicals. So the first step isn't using any of the properties. It's just using what we know about radicals. So I'm going to rewrite this as log of x to the 5th y cubed. Rather than this being under a radical, I'm going to put it to the 1/2 power. The reason we want to write that with a power is because now, in order to separate these, notice it's in the form log base b. In this case, there's no base written, so it's a base of 10. This is in the form log base b of m times n. But since this whole thing is to the 1/2 power, I can't separate these the m and the n until I do something with the half in front, or the half in the exponent. That's why we needed to rewrite the radical, because now this half, I can use that third property and move it to the, so I have the half in front multiplied by log of x to the fifth y cubed. Now I can keep going. So this is in the form, now this part is in the form log base b of m times n. So when I rewrite it, I can rewrite it as 2 logarithms with a plus in between. And as I said, when there's not a base written, it's the common logarithm. So this is a base of 10. So I don't have to write the base in. So when I rewrite this expression, I'm going to have log of x to the fifth plus log of y cubed. So I rewrote this with the plus sign in between. Now, the thing we ought to be careful of, once again, is this whole expression had the half in front of it, or the whole expression was multiplied by a half. So I have to put this in parentheses, and then I still have that half that's multiplied in the front. So let's simplify this a little more. Now both of these have a exponent. So I can use that third property with these exponents. Both these exponents, this 5 can move to the front of this logarithm, and this 3 can move to the front of this logarithm. So if I rewrite that, I would have 5 log of x plus 3 log of y. Now notice I still have that in parentheses, and I still have the half in the front. So you can leave it like this with the half in the front and then parentheses around this. We can also rewrite it by distributing that half. If I distribute the half, I'd multiply this by a half, 5 log of x times a half. That would just give me a 5 halves in the front. 5 halves log of x plus, here if I distributed the half, 1 half times 3 would be 3 halves log of y. So you could either rewrite it with the parentheses, or you could distribute so that you don't have to write the parentheses. So those are the two ways we could write that expression. So that's what it means to expand, is rewrite the single logarithm so that we have multiple logarithms that are either added or subtracted. All right, so we are done with the 4C notes. Tomorrow is Wednesday, so you won't have a new assignment tomorrow, but you will be able to use the time to catch up on things you're behind on, or to get help if you need it. I will still be available during my hours, my question and answer hours from 9:30 to 10:30. All right, everyone, have a good day.